Good evening, guys. How are you? Good evening. Good evening. Can you hear me? Hello. Can you hear me, guys? Very good. So, welcome to. So, I maybe for the first time today you are seeing me live online. There is a reason behind it, and I mean, you should know me in person. I should turn on my video so that we can connect together easily. Okay, so that's one of the reasons behind being showing the turning on the video over here. And yeah, so our plan of today is to solve, as you know, high school mathematics problems, geometry, combinatorics, number theory, and we will start today by a coordinate geometry problem. It's very easy. I'm sure you will find it interesting. Let's go ahead. Okay, I will turn off my video, and yeah. So good evening, all of you. So let's focus on the blackboard. Okay. So here is problem 1. All of you can see the board. The problem 1 tells you that suppose you take a center, a circle with center C, a circle with center C, and it's tangent to the positive x and y axes. Okay, externally. The tangent is also external tangent. Circle is also external tangent to the circle centered at 3, 0 with radius 1. So what are the possible radii of the circle with center C? Okay. So what will be the first step, guys, to understand and solve this problem? What will be the first step? What do you think? What will be the first step? The first step will focus on drawing the stuff, right? So let's draw it. Yes, perfect. So we will draw the stuff, whole stuff. So let's try to draw it and let's see what comes up. So if you draw, so let's do it. So first, 1 second. My computer hanged. Just 1 minute. One minute, guys. Just give me a minute. I cannot move my pen tablet. Just 1 minute, guys. I'm so sorry for this. Yes. So let's do this. All of you can see the hi, Ian. Okay, so essentially we have this diagram over here. So we have a circle with center C, and it's tangent to the positive x-axis and y-axis as shown, and it's tangent through the circle centered at 3, 0 with radius 1. So these are the positive x-axis and y-axis. So diagram is really important. This is a positive x-axis, and this is a positive y-axis, and here is the 3, 0, the circle. Okay, so it's these two circles are tangent to this. So that would be my first question, that why there are exactly two possible circle which are tangent to this circle. Can you help me? Like why there are two possible circles which are tangent to these circles? How can we do this? Yeah, inversion kills the problem, but I will not do those hi-fi stuff. I will approach in a very basic manner. so that it's understandable by most of the people over here, the marks. Okay, so essentially, my question to you is that first you have to guess that how many possible radii are possible. So one way of guessing is that I am leading you through the problem solving steps. Okay, so how will you do it? You will first draw the diagram and guess what are the possible options over here. Okay, so how will you do it? So this is the first step. Sure, I will show the question. Can all of you see the question, I guess? I think yes. So AIM and AMC problems will be really good for problem solving, good problem solving sources for IOQM. You're right, totally right. Good evening, hi. So yeah, so let's try to understand how this is possible. Okay. So what will you do first? Give me ideas, guys. What's your first approach step over here? How will you approach it? So you have 3, 0 circle, you have and x and y axis. So you're sort of bringing a tangent to this. So how will you approach this problem? Give me the ideas. So suppose, so this is the idea. You should understand this. So suppose the radius. So what should be the point of center point of this? You can understand easily the center point will be from r comma r. Is it r comma r? Yes, it will be r comma r, where r is the radius. Why? Because of this reason. The center will be, the radius will be r and r, so therefore it's x comma x, r comma r is the point over here. Okay. So therefore the radius is r comma r. Once you know the radius, it's done. Okay. And here it's also r comma r. So once you know the radius, you know everything about the circle, because the circle center is r comma r and the radius is also r. So essentially once you define the radius, then you get everything about the circle. Now therefore we have to find r, right? So therefore we have to define, so once we know r, the r is the key. R is the key, the very bad key. Okay, so what will you do next? So you have to find and prove. So essentially in this r comma r, you have to only use the information that either is tangent to x and y. But you didn't use the information it is tangent to the circle at 3, 0. Therefore, you have to instill in the information that there is a triangle, like it's tangent to the circle at 3, 0 with radius 1. So how will you instill the information in there? How will you use the information over here? Can someone tell me? Also understanding the steps that are going on here. Any doubts? Equation of tangent, that's okay, but what else? What else? So what is the center? 3, 0. Okay, and what is this center? R, R. Can someone tell me what is the distance between the two centers? The next hint is that distance between the two centers. Can someone tell me what is the distance between the two centers? So see, we are usually asking about, see, I have to understand what we're usually aiming at. We are usually aiming at using all the information out here, okay? So if you are doing it in an algebraic manner, you should instill all the information out here, okay? So what is the information out here? The information out here was r, r. That's a tangent to x, y. It's instilled in this in this information of this diagram, okay? And now you are using the information standing to a circle, which is only, so two circles are tangent if and only if the distance between the center is this radius plus this radius. Okay, so we'll use the information out here. So what is the distance between the center? The distance between the center is, you can write it as r minus 3 square plus r minus 0 square. Iska root over is the distance, which is equal to what? 1 plus r, right? So that's, I also understand why I am doing this step. Because we are using the information that these two circles are tangent. So therefore we are using this step over here. And what's next? So what we have got, therefore let's square it. So we have got r minus 3 whole square plus r square is equal to 1 plus r. So let's just break up terms over here, okay? And let's see what really comes up. So essentially this sort of gives an idea, okay? Let's break this up. Plus 9 minus 6r plus r square is equal to r square plus 1 plus 2r. Okay? So let's this r and r cancels out. And 1 is there. So we have over here minus 8r plus 1, 8. Okay, so they cancel all this out here. 8 minus 8r is equal to 0. So this sort of shows that the two possible only circles are there. Okay? There are only two possible circles because the r is a quadratic equation. Okay? So therefore there are only two possible circles that are possible. And since there are two possible circles that are possible, therefore we have to find it out obviously. And therefore let's find out the r. Okay, let's find out the r. So let's solve this quadratic equation. Can someone tell me? But see, observe one thing over here. What do we need over here? We need what is the sum of the possible radii of the circle. So instead of finding the quadratic like the results by solving it, what we need the sum, right? And the sum can be given by what? If the roots are say r1 and r2, so it can be written as r1 minus r2. So by Veda's formula, r square minus r1 plus r2r plus r1 r2, right? So therefore the sum of the two radius is given by this 8, right? So therefore the sum of the radius is 8. All of you understood? So this is a blend of coordinate geometry and Veda's formula. Okay? Whereas the sum of the roots, how we can find, how can I relate the coefficients and the sum of the roots. Also this gives an intuition that if you draw such a thing, then there are only two possible circles possible. Okay? Shauradip, I really request you to send me your messages in my WhatsApp rather than in Skype because I am not really active on Skype. No, I will not sketch the inversion solution tangent of circle, whoever you are, because that will be a waste of the time for most of the people out here because they don't know inversion. Okay. Yeah, so sure. What will I repeat? What didn't understand, Kanishk? Who didn't understand any doubts over here, guys? Who didn't understand any doubts? Okay, so what we are doing here, first step is, okay, the first step is we should find the quadratic in R. Oh, see, it's R squared minus 8R plus 8, right? This is the equation of of the radius R, right? It's the equation of the radius R. And now in the equation of radius R, we don't want the individual solutions. We want R1 plus R2. That is the sum of the roots. That is sum of the radius. So let's say the radius, possible radius are R1 is R1, radii are R1 and R2. So therefore R1, that equation must be R minus R1 times R minus R2, because that's how the ratio is written, right? I mean the product is written when it has solutions R1 and R2, right? So therefore, when you expand it, you get R square minus R1 plus R2 times R plus R1 R2, right? So what do you get over here? You get that the R1 plus R2 must be equal to 8, okay, by coefficient matching. So therefore the sum of the roots must be 8. That is, the sum of the radii must be 8, the possible radii. I hope you understood this, Kanishk. Oh, no, there's a 1 plus r square on the right hand side, right? It gets cancelled, right, Tishika? No, it gets cancelled, no? Did I do some mistake over here? In minus 6 are over here, it gets minus over here. So essentially, we cancel. This is the equation, right? Am I doing something wrong, guys? Am I doing something wrong, or everything is fine? Everything fine? Yeah, sure. I will repeat the whole thing again. So we have a circle with center C, which is tangent to positive x and y axis, and external to tangent, which is centered at 3, 0 with radius 1. So now our first step is that we draw the figure. The second step is that we use the information, right? So the information is tangent to the positive x and y axis implied by the fact that the center is r, r. Okay, and the radius is obviously r. So therefore, the idea is that the r, the radius r, completely defines the circle. Okay. But see, this information is only using the fact that it's tangent to x and y axes, right? So therefore, we need to use the fact now it's tangent to the small circle which is centered as 3, 0. Right? So to use that information, what we're using is that the distance between the two centers of these two circles is what? It's r minus 3 whole square plus r minus 0 whole square. Uska root. Which is equal to 1 plus r. Why? Because the distance between two tangent circle is the sum of the radius. We know the radius of the big circle is r, and the radius of small circle, I shouldn't say big circle because there's another circle over here option. So this circle is, unknown circle is r, and the smaller circle is 1. So it must be r plus 1. So you square it, you get a quadratic in r by cancelling each other. So therefore it tells you that exactly two circles are possible. Since there are two radius r are possible. Did you understand, Ahana and Kanishk? Any doubts, guys? Any doubts? Any issues over here? Did you understand how we use all the ideas together to solve the problem? Now we will come back to the final sum. Fine. So now, what you do is that you sort of solve this equation. Now the idea is that r1 and r2 are the roots of this, like the possible radii. So r1 plus r2 is given by the 8. Because if r1 and r2 are the possible radii, that is solutions of the equation, this quadratic by fundamental theorem of algebra can be sort of factored into what? Into r1 minus r minus r1 and r minus r2, right, guys? Right, I hope you got it. And then when you expand it, you get r minus r square minus r1 plus r2 r plus r1 r2. So we see that r1 plus r2 is given by the coefficient of r, right? Negative of the coefficient of the r. So therefore, it's 8 is the sum of the roots. Okay? All of you understood? All of you understood, guys? Very good. Let's move on to the next problem, guys. Very good. Okay, so next problem, guys. So let's move ahead. But before I move on to the next problem, let me share another idea with you. So essentially, if you observe my lectures, I usually give extensions of these problems. Okay. So one extension of this problem led to a good research, going to a good research paper soon by one of our students of Cheenta. So I want to give more extension of these ideas so that you can publish or you can think about these new problems. So what are the extensions possible? So instead of this circle, so it is not for the exam purpose. It is for the purpose of the more exploration purpose. Okay. So consider instead of these circles, consider spheres. Okay. So they consider three-dimensional place, and you consider spheres. So you think that the three-dimensional sphere is tangent to the xy plane, yz plane, and the xz plane. Three planes are there, right? So when you do this, and also take a condition that it's tangent to one of the circles, which is centered at 3, 0, 0 with radius 1. So now my question is to you, how many such spheres are possible? What are the possible radii? So you will find out magically that it's coming out to be a 3-degree polynomial, okay? And you can find the sum of the roots. So it's a general extension of the problem. You can find it in a much more general manner, okay? So therefore you can find it over there that, so if you can extend it to a n-dimensional sphere, okay? Then you can see it will be an n-dimensional, it will be n-degree polynomial out there, okay? So this is the connection between how polynomials comes up, how many possibilities comes up, and with the increase of dimensions, okay? That's the idea. So you can think about this problem if you're interested enough. If not, you can move ahead to your own problem solving cohort, okay? Exactly. For n dimensions, it will be n-dimensional, n-degree polynomial, and the now it will be an n-degree polynomial, and in the n-degree polynomial, for the same purpose, you can use extensively the idea of Vieta's formula. You should go and search in the Google the idea of Vieta's formula. What is Vieta's formula, and how we can connect the roots of the polynomial and the coefficient of the polynomial. So this is the idea. This is how you do extensions. So when you are doing a problem, don't just stop there. Go a step ahead and explore yourself. That's where the adventure of mathematics comes in. Okay. So let's not make it much more delayed, and let's move on to the next problem. Okay. So next problem now. What's the next problem? The next problem revolves around. Can you guess what the next problem is? Revolves around an algebra problem. Okay. So I'm much more focused on algebra. I'm usually focused for the past few days on combinatorics and probability. Now I'm focused on algebra, coordinate geometry, and stuff like this, so that it's really easy and you can really connect with it. Okay, so it's an algebra problem, APGP problem. I'm sure you can find it really easy if you just focused on it. So yeah, I will surely give you time. So do you want me to count and start my counter on, that is 30-second counter on, or it's fine with you? So all of you can see the problems, guys? Okay, I will give you a few minutes to think about it. Actually, this is a YouTube live, so keeping a bit of pause will sort of give like awkward silence among the people. So that's why I'm going a bit fast. But okay, so I will talk in between. Okay, so just okay, so that's a good question. AR plan are two different geometric infinite sequence series. No, okay. Sum of the first. Okay, yeah, it's assuming that R1 is less than 1. Also understood why it's a very valid point. Why R1 is less than 1? All of you understood why it's a very valid point? Because without the R1 less than 1, the series will not converge to a number. It's given the sum of the first series is R1. It's an infinite series. So let me revise about the infinite series. So how do you find an infinite series? So let's say S is the sum A plus A R1 plus A R2 plus, sorry, R1 square. I'm so sorry. And it continues, okay? So observe that if you go over here, let's take the nth term, okay? Let's take the nth R1 to the power n. So it comes up that it's A common. 1 plus R1 square. It's like this. Plus or R1 whole to the power n. If you just solve it, it will come out to be A times R to the power n plus 1 minus 1 by R1 minus 1. Okay. So this will come up, right? So now observe it very carefully that if you take this limit, if you take the sequence over here, Sn, if you take this sequence, this will, as you go in, keep on increasing n, okay, this will go to infinity, okay, and this will go to, it's natural. Suppose you take 1.5 and you keep on increasing the n, right? It's becoming more. So you have seen this sort of very important aspect of productivity. I'm just telling you because there's a result like this, that 1.01 whole to the power 365 is sort of, I forgot this. It's an important lesson. So I'm just know this. I mean, essentially it's 37.78. Okay. So I'm just telling you because it means that even if you do a bit more than 1 every day, it can become very huge. So that means it's sort of a compounding effect. Okay. So similarly, it's like growing exponential stuff. So therefore, its idea is that R1, when it's more than 1, it goes to infinity. Okay. If you keep on increasing the n. So therefore, if R1 is greater than 1, it will go to infinity. If it's equal to 1, it also will go to infinity because A plus A plus A plus A, it's NA, which goes to infinity, okay? If A is positive or like whatever it is, goes to infinity or minus infinity depending on the sign of A. So essentially, it's not finite. So essentially, we need R to be less than 1, R1 to be less than 1 for it to converge, okay? And it converges. So R1 is less than 1, R1 to the power n, when you increase R1 to the power n to the power n to the power n, if it's less than 1, it's go to 0. It goes to 0, okay? It's very natural. Why? Because R1, if it's less than 1, let's take 1 by R1, which is greater than 1, right? Now, we know that 1 by R1 whole to the power n will go to infinity. So, therefore, R1 whole to the power n is equal to what? 1 by R1 whole to the power n, which is equal to 1 by infinity, sort of, which goes to 0, sort of. Therefore, it becomes small and small and small, and therefore, it turns out to be A by R1 minus 1. So, it sort of converges. It's sort of becoming more close if, I mean, towards its converges, goes to a central value as n is increasing when R1 is only less than 1. So that's why people told that tangent of circle. I really would like to know the name of the person. Tangent of circle. It's very odd to call it tangent of circle. Also, it's a very long name, so it's kind of wasting a bit of time for me. So I would really like if you can reveal your name to us. Otherwise, I will like to call you tangent or something. Anyways, so therefore R1 is less than 1. It makes sense, right? So therefore R1 and R2 must be less than 1. Why? Because the reason is that it must converge, and it's given in the problem that both of the series converge to the same value, that is R1, and the next converges to R2. So what is the value of R1 plus R2? So what we have got? We have got the limiting sequence is what? For first one, the limiting is A by 1 minus R1. And the second one ke liye A by 1 minus R2, right? We know that it's R2 and R1 over here. So it's given over here. So now what is the next step? Just solve the equation. Hi Shubham. Welcome. I would really like if you give your name. Also, you can increase your fan followers from here if you want to. Nobody would like to follow tangent. Everyone would like to follow Shubham. Okay. Okay, so that's the idea. Okay. So all of you understood this step why it's going towards A by 1 minus R1. All of you understood this? Did you understand, guys? Tishika, Ayan, Ahana, did you understand? Any doubts? Okay, so now think about this problem, guys. Very good. Nice. Yeah, Devang, tangents is really good and different. Tangent is also beautiful, but you know, there's so many tangents, people will confuse. Okay, so what's next? I will give you a few minutes to think about it, guys. Very good. Thanks, Shubham. Okay, perfect. So, perfect. So, what do we need to find here, guys? We need to find here the sum of R1 plus R2, right? So, how do we find the sum? So, let's try to solve this equation. Or do we need to solve this equation really? What do you say? Yes. So, essentially, that's the idea. So, A is equal to R1 minus R1 square, and here A is equal to R2 minus R2 square. So if you equate that, you get R1 equal to R1 minus R2 is equal to R1 square minus R2 square. So you get R1 minus R2 times 1 minus R1 plus R2 is equal to 0. And therefore you get that R1 plus R2 is equal to 1. Also answers to the simple algebra. No Vieta, guys. No Vieta. Always everything doesn't hold in a single way, right? Yeah, you're right. You're right. That also is a very good way to understand it. You're right. Yeah. Devansh, you're right. Yeah, it also can be done by Vieta, but it's easier to do it by this way. But you're totally right. So what Devansh is telling is really interesting and beautiful. So R1 and R2 are roots of both the equations. What? R1 and R2 roots of R1 and R2 roots of equation R square minus R plus A, right? R1 R2 equates the roots of equation of both this quadratic, right? R1 R2 are roots of this equation. So therefore the sum of the roots is 1. Very good, Devangsh also. Yep. Sure, you can surely get help from us, Shugata. Yeah, we have our ISI math team, right? So you can surely get help. Okay, so any doubts from your side? So now think about it. I will again extend this problem similarly. So you have say 10. You have 10 such geometric sums, and all of them converges to the Ri, the corresponding sorry, the corresponding what is told, it's I forgot the name, the common multiplication term, whatever it is, it's called. So the rate of motion, okay, the R1. So everything converges to that. Then what will happen? So you have three equations, say R1 square, R2 square, R3 squared, or Rn. So what will happen in that case? Also, if you think about, instead of that, different manner, okay, in a cubic form. So that's the question for you guys, okay? How can you really extend this problem to a higher dimensional problem? How can you make a different problem of yours from this, okay? Or rather, you can ask yourself that instead of R1, what if it's converges to twice R1 or some constant times R1? What will happen in that case? That's a general question. So whenever you're facing a problem, don't just stop there, okay? Think and explore in that. Okay, so that will be really interesting, and that will be really, and that tinge of adventure will slowly come into your mathematics, and you will really enjoy the subject, and also statistics, whatever you are studying. Yep. So that's the idea. So we can have another GP for R1. There's R1 square, right? So you can do it R1 cube, right? So it can come up, or it's sort of R1 square ka GP. The ratio is there. So there are a lot of opportunities over here. You can just play around with it. I will not waste much time on this. Let's move ahead to the next problem. Okay, you have any queries from your end, guys? Otherwise, I can move ahead. By the way, we have a live session for you guys with our people who got into ISI and CMI this year. I will be going live with them, and I really want you to come and give your queries. I have given a form to you. I will give a form to you rather to give your queries. But yeah, so I would love to see you there, and I would love to have your queries so that we can make it the best. So also for the statistics students out here, we are also arranging the live session with our ISI Instan and ISI and IIT Jam MS Scholar people. So I would love to have your queries so that when we go live, we can answer your doubts. Okay. So I will turn off my video and I will focus on the next problem. See you in the next problem. Okay. So yeah. So regarding your doubt, Shubham. Okay. So regarding your doubt, I want to tell you something. That this problem solving is really not tricky. Okay. There's a certain algorithms. So what are the algorithms I usually tell my students? Okay. When I follow, well, what I follow rather personally, the algorithm is very simple. It's like when you're given a problem, just, I mean, there kind of two possibilities. Okay, you can sort of think that, okay, I've seen this problem before, maybe I can approach it in this way. Okay, and or you can not approach it anyway. Okay, whether it's a problem of mathematics or statistics, doesn't matter. You cannot approach it anyway. So now if I cannot approach it anyway, what to do? Okay, so what to do is, the idea is that you should take examples. Okay, so suppose you are solving number 3 problem, you should take examples. So if you read the book of How to Solve It by Polia, you will understand clearly. So you should take easier examples. Okay, it should be easier examples, and you should explain it in a much more like you can get the hint of how to approach it. Okay, that's the idea. Okay, so that's really interesting. You can try it out. This is the first step you should follow, and then you can find out links and here see the pattern in between the observations. For example, suppose you are asked to find a solution of a very complex Diophantine equation. Okay, so what you do is that you take modular part, you reduce the problem, and you see the easier problems, guys. Okay, so that's the idea, and from there you can do like you can approach, you can do it in a different manner, in the sense that you can play around with it and you can take examples and see a pattern in between. Okay, so that's the idea. So that's the first step, and then you can move it to the next part. Okay, so let's come back to this problem. Okay, very good. I'm so sorry. How did this? Okay, so let's move ahead. The next problem. Okay, so what's the next problem? The next question, number theory. Okay, I like this problem. Let's do this problem together. Okay, can all of you see the problem, guys? So maybe this is the last problem for today. Can all of you see the problem? Others can see. Very good. So the problem focus on the fact it's a number theory problem. So it focuses on the fact that it's given a number ik, which is 1 0 0 0. There are k zeros in between. That's why the k suffix is coming up. And between 1 and the 6. Okay. And the nk is the number of prime factors, number of factors of 2 in the prime factorization of ik. So what do we mean by factors of 2? Can someone tell me? Yes, so that's the first idea, guys. So what you will do, guys, is to express, perfect, Shubham, is to express this problem into, what will you do is express this problem into what? Into an algebraic format. Okay, in an algebraic format. Okay, guys. So how to do that? That's the idea. Yes, perfect. So that's the idea. So how will you do it? So what is this form? 10. So there are k zeros, right? And then there's 6, 4. So it is 2 over here. So how many zeros sort of? It's 10 to the power k plus 2 plus 64, right? This is the n. This is the n over here. All of you understood this step, guys? Okay, it may be pretty. It's old is gold, you know, Raghav. Hello, Rohan. Yes, so now, therefore, first we will actually sort of, yes, so that's the idea. So, yeah, you're right. So, you will do this idea of, you will sort of, first idea is to algebraify the problem, okay, into this 10 to the power k plus 64, k plus 2 plus 64, right? So, what's next, guys? What's next? So, nk is asking to the number of factors of 2 in the prime factorizations of ik. What do you mean by number of factors of 2? Can someone tell me? What is meant by number of factors of 2? What are the number of factors of 2? What do you mean number of factors of 2? Can someone explain what's going on in his or her mind? What is the meaning of factors of 2? See, unless you understand the problem, it's not really useful, right? So what is the factor of 2, guys? Before moving on to the answer, what is the meaning of the factor of 2? Number of 2? Yes, perfect. That's it. How many 2's comes up in the prime factorization of IK? Perfect. Perfect. That's it. Yes. So how many factors of 2 are there? Perfect. Very good. So therefore, it sort of disguised the problem in a very different form. That how many rather what is the maximum power of 2 that is possible over here? Okay. Maximum power of 2 what is possible over here is 64 is what? 64 is 2 to the power 6, right? This is very easy, right? This is very easy. It's 2 to the power 6. So what it can do is that 2 to the power 6 into this whatever 5 to the power that into something plus 1. So this is a 2 to the power 6. Maximum value of nk is 6. It's a very easy problem. This can come, but in a much more in a different manner, okay? In a different manner. But rather it can come what is the maximum instead of nk, it can tell that what are the sum of the divisors of the power, okay? So in that sense, it will sort of measure your understanding in the sum of the divisors, okay? So let's move to the next problem. It's a really easy problem. Yes. No, it's really easy. It's a maximum power going to 2 to the power 6 because the rest will be then odd, right? That's the idea. It's a really beautiful problem. And a cute problem. But see, for k equal to 4, we have got 2 to the power 6 into 5 to the power 6 plus 1. So it's not over yet. So don't think it's over. Yes, I didn't tell it's over. The idea is that for k equal to 4, you get 2 to the power 6 times 5 to the power 6 plus 1, right? Now this is also divisible by? This is also divisible by 2, right? How much it is divisible by 2? That's the idea. 2 to the power 6 times, what is this? How much it is divisible by 2? Can someone tell me what is the maximum power of 4 that can divide this? What is the maximum power of 2 that can divide this? Yes, it's not over. So 2 to the power 6 is not the idea. There's something more. So what is so 5 to the power 6 plus 1 ka kitna 2 ka prime factor hai? That's the idea. Okay. So can someone tell it to me? Can you prove that 4 doesn't divide this? 4 does not divide 5 to the power 6 plus 1. Can someone prove it to me? It's really easy. Why 4 doesn't divide it? 4 divides 5 to the power 6 minus 1, right? Suppose 4 divides, 5 to the power 6 plus 1. Therefore, it implies that 4 must divide 2, right? Which is not possible. So, therefore, 4 does not divide this. Okay? Don't go into modulo. Don't go into modulo. You are so becoming so, I mean, you're also rich, now. You're also rich in mathematical knowledge. I'm just using very poor stuff. Try to be, yeah, don't try to show off your mathematical skills, okay, in that sense. You just do easy stuff, okay? So 4 divides 5 to the 6 minus 1. 4 divides 5 to the 6 plus 1, let's assume. And therefore, by simple addition of divisibility, we get 4 divides 2, which is not possible. So therefore, 4 cannot divide 5 to the power 6 plus 1, right? So now, therefore, what is the idea? Therefore, we know that it's odd plus odd, so 2 must divide it. So the maximum 2 ka power that can divide this is 2, right? So therefore, it's 2 to the power 7. All of you understood this? Why it's root to the power 7? Yeah, all of you are right. Dhruv, you're right. Why is Dhruv so excited about being right or wrong? But I mean, I thought Dhruv told 7, right? That's why I told Dhruv is right. I mean, if you have told 7, you're right. If you have not told 7, you are not right, okay? And I don't know who have told 7, I have not told 7. Okay, I need outs till this point. I hope you're understanding, Ayan, Tishika, and Ahana. Are you understanding, guys? Sure. So all of you know that 4 divides 5 to the power 6 minus 1, right? Right? A minus B divides A to the power n minus B to the power n. So you know this. So let's assume that 4 divides 5 to the power 6 plus 1. So if you combine these two, what do you get? If you add this two up, if A divides B and A divides C, then A must divide B plus C, right? So we are using that same property. We get that, sorry, A minus B minus C and B plus C and B minus C. So it divides 5 to the power 6 plus 1 minus of 5 to the power 6 minus 1, which is equal to 2. So therefore we get 4 divides 2, which is really absurd. So therefore this assumption is true, therefore this assumption must be false. So therefore it cannot divide it. This is called the idea of divisible. This is actually called the idea of contradiction, the method of contradiction. Okay. Okay. Very good. Are you comfortable with this? So let's move on to the next problem, guys. I didn't get the reply of Tishika, Hana, and Ayan. Are you here? Are you understanding? Next, very good. See how my school friends like Orko Jyoti is coming up and spamming the thing. That's good. Thanks for being a member of this live, Orko Jyoti, and welcome to Cheenta. Okay, so good. I like this, you know. Okay, so let's move ahead to the next problem. Okay, Tishika. Okay, so I hope you remember divisibility, Tishika. It's really, it's okay. You just let me know, okay? Let me know in your one-on-one doubt clearing group, Tishika. Okay. Okay. So let's move on to the last problem of today. We have just 7 minutes left. So what can we do? In 7 minutes. Okay. So in 7 minutes, we will not solve the problem. We'll discuss the problem. It will be given as a homework to you. Okay. So Andrea inscribed a circle. Thanks, Orko Jyoti. And I'm glad we connected over Cheenta via YouTube. Please ping me in WhatsApp, Orko Jyoti, okay? I lost your contact. Okay, so problem 4. Andrea inscribed a circle inside a regular polygon. Sorry, pentagon, which is a polygon in fact. We circumscribed a circle around the pentagon and calculate the area of the region between the two circles. So what is done? Andrea draw a circle inscribed within a pentagon and subscribed outside the pentagon, okay? And so Pinaki can send the solution in the comments or in Beautiful Mathematics group. Okay. and he calculated, or I'm not sure, Andrea is she, maybe she calculated the area between the two regions of those two circles. Okay, so now Bethany, her friend, did the same with a regular heptagon. Okay, and the radius between the two regions are A and B, and each polygon has a side length of Q. So which of the following are true? So now what are the following options? So I missed to give that. Oops, I'm so sorry. I missed to give the following options. I am so sorry. This is a general what? This is a general? Okay, let me find the solution, or the problem ones rather. In the meantime, you just stay tuned with me. Okay, so let me give you the options. Yeah, options are here. Actually, I am so against options now. I always overlook the options. I really don't like the options in my life, because options reduces your focus. So if you got the options over here, we can give a diagram surely, but diagram not really useful once you know the results in here. Okay, I will give you a hint with a hexagon, okay, and you do the rest. Oh, let's do it for pentagon. Let's do it for pentagon. You do it for the hexagon, and just find out the result, okay? So let's do it. Let's take this is a regular pentagon, and you draw a circle inside it. See, the main idea, guys, is what? Can you tell me? The main idea is essentially the radius of the circumscribed circle and the inscribed circle, right? No, I mean, this is the homework problem, Piyush, okay? So the idea is that the only importance of this problem is to find the radius. That's why please don't utter the options over here. That really bothers me. Okay, options actually get on my nerves sometimes. So if you want to irritate me, then give options and tell the options rather than explaining me. Okay. Okay, so the idea is that you have to find the radius, right? You have to find the radius of the circle, of the inscribed circle and the circumscribed circle. So how to find the radius? So let's understand how to find the radius. So this is the center, and this is the perpendicular. So this is perpendicular to the radius, right? So essentially, if you know, so all these triangles are congruent, right? So therefore, you just need to know the angle theta of it, and you know this length is 1, right? Because its side is 2, therefore this length must be 1. So what is this height? Can someone tell me? It will be tan theta. So you just need to know the tan theta of this. So that's the height of this. That is the radius of this. And this is what? This is the radius of the circumscribed circle, right? Right? So this radius is what? This is base by hypotenuse. That is, it is base by hypotenuse is what? It's cos theta, right? So it is cos theta. I'm so sorry, it is sec theta, 1 by cos theta. Okay? So therefore, what do we get? Sec theta is a bigger circle radius, so let's do it square, and tan theta is a smaller circle radius, it's tan square theta. Okay? And there's a radius, and if you do pi over here, the pi is what? It's same pi, right? So A is equal to B. It is independent of the theta over here, right? It's simple. It's simple, right? It's independent of the theta over there. It's independent of the circle. It's independent of the pentagon and the hexagon or whatever you take in the dodecagon. Okay, you can take octahedron or whatever you want. Okay, you can give it a name. Okay, so any name you want, and you can find the difference in the two areas. So this was a theorem, yeah, but it's really easy to see, right? It's just an application of the result that sec squared theta minus tan squared theta is equal to 1, which is essentially an overrated version of, it's an algebraic version or overrated version of the Pythagoras theorem, okay? Just Pythagoras theorem. All of you understood this, guys? Any doubts? I think it's an equivalent theorem of, it's an application or corollary of the Pythagoras theorem. Like I think people shouldn't do this. I mean, it shouldn't be called, it's an extraordinary freaking theorem by Gauss. I shouldn't take that. But okay, you didn't understand this? Okay, Tisha. Did you understand what do you mean by the external radius and the internal radius? So the radius of the circumscribed circle is this, right? Is this, right? Radius of circumscribed circle. And this is the radius of this is the radius of inscribed circle. Did you understand this hint? Piyush, then let's wait for the next beautiful mathematics seminar. I have finished all my problem list for today. It's good that you have done it quickly, Piyush. Okay, very good, Tisha. Now what's next? Now you are trying to see the difference in the two areas, right? Now what is the area of the bigger circle? Is pi sec square theta, right? And what is the area of the internal circle, the inscribed circle? It's pi tan square theta. So what is the difference? It's pi common sec square theta minus tan square theta. Now sec square theta minus tan square theta is 1. Simple stuff. So therefore, it's the difference between the two squares, of the, and rather the difference between the two area of the circles is just pi, Tisha. Okay? Just pi. Simple, beautiful, elegant, and cute pi. Okay? And why this is cute? Because whatever theta you take, observe the theta, internal angle ka half theta is varying with heptagon, hexagon, octagon, whatever you're thinking. Okay? So therefore, it is independent of theta. That's a beautiful. It's called invariance. Okay? So the difference between two areas is invariance. It's invariant. Okay, it's really beautiful. I love this result. Okay, all of you understood this? Tishika, Ahana, and Ayan, did you understand, guys? And others who are from statistics background. Now okay, so let's end this problem. So I will again end with a beautiful 3D wala version of this, ND wala version. You can, in dimension, you can sort of think about it. Now think about a sphere, okay? Or think about an n-dimensional or 3-dimensional regular platonic solid, or solid maybe. Let's say tetrahedron, okay? It's a uniform solid, right? Now consider a sphere inside it, inscribed inside it, and consider a sphere just touching the surface. Now, can you find the difference? Can you find the difference of the volumes of there? It is constant. Okay, that's a 3-dimensional extension of this problem. I don't think it's a platonic solid. I think it's something different. So what you can do is that you can sort of extend this from the 3-dimension, and this can be a good research problem for you. Okay. So as I told, one of our problems have been solved, has been transformed into a research problem by one of our students called Ishishwini Mathur, and she's working on it, and we are working on it. We are planning to publish it if it's good enough, and we are really planning to engage more of these activities into a research track PRMO of Cheenta. I think most of you can give your bit and make your professional or mathematical career much more exciting, because you're going to apply in mathematical summer camps, or you're doing what and whatever you can do in your future, but this will really stay in your life as your research work, because the research is really highly appreciated all over the world in anything what you do in mathematics, since you're in mathematics. Okay, so okay, you can work on that surely, but I want you to work on this problem. So I want to take this problem seriously and work on it. Okay, maybe you can do simulations of it. Maybe you can draw diagrams in 3D. You can do it. Okay, Now, research problem is that, see, a research problem is not like you have to do hardcore research, you can get the Fields Medal, okay? That's not the idea of research problem. The research problem is to shun your gray matter and shun your research wala idea, okay? Which can make you a good problem solver, okay? Which can let you make you a good problem solver. Even if you're looking for a job, it's a really high opportunity for you in the lot of industries over there, okay? So, okay, let's not go into this aspect. Also, reminding you of the live session we are having soon in ISIM Sun IIT Jam Statistics part and the ISI CMI 2020 batch of Cheenta sharing their success story, sharing their preparation plan. Sure, you're welcome to it, and we can start. Which problem? Okay, the problem is that we have just done the two-dimensional version, right? There's a pentagon and there's a circumscribed circle and there's an inscribed circle, right? Now, what you do is that you think in your mind's eye about in a 3-dimension. So you have a regular 3D polygon, not a polygon, solid, okay? So you have to understand first what do we mean by a regular solid in 3-dimension. And now consider a sphere around it, circumscribing it, just touching it, just mildly touching it. And consider the internal wall of sphere just mildly touching the faces, okay? It will not touch the sides over it will touch the faces. Now find the difference between the two volumes of those two spheres and now see whether it's invariant like this, okay? Whether it's really dependent upon the sphere or not, upon the solid or not, okay? That's an interesting problem. Okay? So let's wrap it up today here and see you in the next class and good night all of you. Bye-bye. I hope the class was interesting and please stay tuned with us. Bye. Essentially, which day? Okay, I will mention that in the Skype group. Okay, Shivanjan. Okay. Bye-bye. I'm ending the broadcast now and see you soon. Bye. You want me to repeat that question? So take the 3-dimensional solid, regular solid. What do you mean by regular solid? You have to first make sure, you have to first research and understand. You know what is a regular polygon, but you don't know what is a regular solid, 3D solid. And if you know what is a regular 3D solid, you consider the inscribed wall of sphere, you consider the circumscribed wall of sphere, okay? And take the difference of their volumes and see what's the difference of the volumes, whether it's independent of the solid or it's dependent upon the solid, okay? Let's see. Bye-bye. Good night.